What type of stationary point does y equals x to the 4 have? What is the value of the second derivative at this point? Y equals x to the 4, you should know what it looks like. This was in the Year 11 course. It looks a bit like a quadratic, except that it's flatter at the bottom. It's symmetric and it's steeper up the sides than a quadratic. But the point is, at the origin here, it has a local minimum. But if we start with y equals x to the 4 and we differentiate that, and we look for the turning point, which is where dy dx is 0, so 4x cubed equals 0, implies x equals 0. And then we do the second derivative. That's going to be 12x squared. And that means that the second derivative, when x equals 0, is 0. So, the second derivative is 0 at this turning point, and the turning point is a local minimum. So it seems that we can't necessarily identify horizontal points of inflection using a second derivative. So try to remember this example. We will be considering the implications of this when we look at the second derivative test for turning points, whether we have a maximum, a minimum, or a horizontal point of inflection, which is coming up shortly.